All right, I think I'm going. I don't get my prompt anymore. So I had an argument with my little brother the other day, and um, the thing that I love about arguing with him is being right. And sometimes when he's right, I am pleasantly surprised. Anyway, it got me thinking about numbers, and I was looking at the numbers here, and they shifted a little bit. I thought it was interesting, so I played around some stuff, and I want to kind of show what that is. Also, too, just to give a better understanding of what these charts are and kind of how they work. So, uh, first things first, this is basically what our average return is per month, all right? And that's for the total life of the fund. This is the average return per month for the last 12 months, and then this is the average month, um, average return per month over the last 3 years. And so, what I'm looking at here is the fact that basically I have increased the return per month, right? Um, but looking here at the standard deviation, you could also see standard deviation is how much the returns move around from that average, right? So every month you're not going to be at 0.62%, right? I mean, some months you're going to have a 3% return, some months you're going to have a 3% loss, okay? And so what the standard deviation does, it says how much will the returns move around. All right. And so for the life of the fund, you see that it's pretty high, 2.4 percent compared to the last year and the last 3 years. And so what this means is that not only did the average return increase, but the risk also decreased. Okay. And so that means that in the past, uh, there's a higher chance of us losing money on a month-to-month basis. And as the fund grew, as the fund got better, of course, the risk of losing money came way down. But making money went up. Not way up, but it went up, right? And so that was really cool to see. Um, the other thing is this. So on the previous videos, you've always seen 70%, 95%, and then 99%. Okay. And so the reason why I want to show is because what I am using are the empirical rule. Okay, the empirical rule, and this is what the argument was about, right? Are some numbers made up? And of course they are, right? Um, Math needs a constant. Math needs a number that stays the same no matter what in order for formulas to work. Okay, you cannot have a variable number that's always different. Just you can't calculate anything that way, right? You have to have a number that's always that number and never changes, and that's how we get the speed of light and so forth. But we know the speed of light is not constant. It depends on what that light is moving through that changes the speed of light. And so the light that's literally coming to us is not coming all at one speed. It changes depending on what the light is coming through. So the speed of light changes. All right. Anyway, so the point is nothing is ever static. But in order for math to work, you have to come up with these static numbers. All right. And this is just one example. So this is the empirical rules, 68, 95, and 99. Um, and so that's what I've been using. So when you see that 70%, that's the 68, the 95, and then the 99. All right. And what this means is that statistically we can calculate, um, 68% of the time what's going to happen with any event. Okay. In this case, we're talking about returns for the portfolio. All right. So at 70%, we expect that the portfolio is going to return either 1.83% per month or it's going to return a negative 5.8% per month. Okay. We can predict that at 70% accuracy. Okay. As we get more accurate, the numbers get larger because it's trying to encompass more data. Okay. And so when we get to this 99, now what's interesting about this is, again, nothing is ever 100%. Can't be. Okay. I don't care how many standard deviations you put on it. It's going to be a number that approaches 100, but not getting to 100 because nothing is perfect. There's no absolute zero and there's no absolute 100 either. We do have terms that we use to explain these things, but mathematically, we have to know that they aren't real, right? So, um, the question, though, and that's what's interesting about statistics, is at what point do you decide that something is 100%? So that's what we're going to look at. So again, we got 70%, 95% accuracy, okay, and then 99.7. It simply means that, 95% of the time, right? 95% of the time, you know that you're going to be able to predict that this particular portfolio will either return 4% or it's going to lose 4%. Okay, and that's based on the total history of returns. And we see that uh, just 1 year ago, right, in the past year, their number was 2% per month or losing a negative 1%. And so what that means again is that the portfolio has gotten better at not losing money, not necessarily making money. Case. All right. Over the last 3 years, the number is a little better. Um, it could possibly get 3% per month or lose roughly 3%, so 2.75. So a little better than the total history. But this 1 year, I think, is really telling. The other thing is that returns are coming down. Now, I'll discuss that in the market update video. But either way, and then 99%, and again, this is 99.7, right? So we call that 100% because you can round up to 100%. So there's a 100% chance that this portfolio is going to return 10% per month, or you're going to lose 9% per month. Okay, and so what I did was I just looked back over the history of the portfolio to see if I can find any 10% positive months. And as you can see, you go down the list, there aren't many. There's a -9, okay, but there's only one that goes above 10%. And so what that means is that the more accurate you become, the less chance of it actually hitting these extreme numbers. Okay. And so that's the reason why typically I use this 70% to give me a really good idea of what I can expect month to month. Okay. Now, um, with that being said, so what I did was, again, I've been using the empirical rule for so long because it's a lot easier. And let me explain what I mean by that. So this is a Z chart, all right? And so it's fairly simple. What it says is at Z of 0, all right, there's a 50% chance that the average will happen. So remember, the average return, the average return for the total history is $200 a month, okay? $200 a month, that's the average. You can expect that. So next month, me predicting that I'm going to make $200 is a 50-50 shot. Okay, 50-50. You can't really make any decisions on 50-50. All right, and that's where statistics comes in. All right, now what you can do is you can use this Z number, all right, to increase your accuracy. So instead of a 50-50 shot, you can simply use this number down here, 0.05, and you can raise it to now a 52% chance. Okay, so as the number gets larger, the accuracy gets larger. Okay, when we get to 70%, that's right here. All right, that's 0.51. All right, now what the empirical rules say is that one standard deviation is 70%, but that's just a roundabout figure. Okay, it is pretty much made up. All right, and the reason why is because technically, once you get past zero point 0.5, you can round that up to 1. So you could say 1Z, one standard deviation, is 70% accuracy. Okay. But in reality, the actual numbers, if you use the actual numbers, it's really zero point 0.5, and it makes a difference. And so that's what we're looking at here. So um, this is what I usually show in all the videos. It's actually 84% accuracy, but conservatively, empirical rules, we say 70, right? Just 70% chance that you're going to hit these numbers next month and every month thereafter. Okay, 84% chance. It's going to be anywhere between negative 1.7 and positive 3. Okay, it can be any number in between those numbers, but it's going to be between those numbers. And that just says that we know that we're not going to lose more than 2% a month. Not going to happen. 84% chance. 16% chance that we do, right? But 84% chance that we won't. And so typically, again, these numbers, I'll show them, I'll list them at 70%. But in reality, mathematically, they are actually 84%. And that's shown right here, right? One standard deviation of Z gives you accuracy of 84.13. This is what the formula looks like. Okay, so Z is the number you're going to use. This is the standard deviation, which you know just because you have the data in front of you. X is any random month that you want to choose, and then U is the average. Because once you have so many months of data, you can come up with an average return, right? And so that's what allows you to predict month to month what you can expect from the portfolio. And like I said, I think it works fairly well because 99% chance that you're going to get 10%, and we actually hit 12% one time. Um, Other than that, there's a 8% in there, and I don't think I saw a positive 9. Yeah, no positive 9s. And again, this goes back to 2016. We have been existing since 2015. I don't have that data though. So anyway, yeah, thought that was interesting. The other thing is, I had it queued up. Oh yeah. So at what point do you decide that something is 100%, right? Do you decide at 90% because you know that there's only a 10% chance that something is going to happen? If there's only a 5% chance that something is going to happen, do you say that's 100%? If there's only a 2% chance of something happening, is that 100%, right? And so these are decisions that we make as humans. The problem is that without statistics, you can't mathematically explain how you're making that decision, right? So, like if you walk outside your house, you know that there's a chance that you're going to be hit by lightning. That chance may be very small, but the chance is still there. Do you say that there's a 100% chance I won't be hit by lightning if I walk out the house? You may not even say the word 100%, but you will say something like, well, if you walk outside the house, you won't be hit by lightning. Matter of fact, if you're talking to another human being that says that they're afraid of walking outside because they'll be hit by lightning, most people will tell them, hey, don't worry about it. Chances are you're not going to be hit by lightning. Right? I mean, you'll say to yourself, well, the weather, clouds in the sky, maybe time of day, maybe season, right? But the point is that I don't care what the weather is. I don't care what time of day it is. I don't care where you are. There's always a small, very small chance that you will actually be struck by lightning. The question again is, how small does that chance have to be before we disregard it, right? And so personally, when you talk about a risky person or risky personality, I think, right? I think that I can shave off 20% and still say that's 100%. These are very real conversations that happen specifically in the medical industry, right? So if you have a medicine that you are experimenting with, and 1 out of 100 people died from using that medication, that's a 99% success rate. That's going to pass FDA approval all the time. That's going to happen, right? Um, Now, of course, that's really simplifying things because it depends on at what phase this happens and depends on why this person died, whether there are other comorbidities, blah, 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 right? But the point is that the FDA, I mean, the fact that there's a 100% success rate almost never happens. right? There's going to be side effects. There's going to be failures. But at what point will you say, hey, you know what? This is okay, right? Is that 92%? Is that 93%? Is it a 5% chance that something bad will happen? Are you okay with that? Are you okay with a 10% chance of something happening? And then you have those who are risk adverse that you talk to, and they say that they're not even comfortable with the small percent chance that something bad is going to happen, right? They are looking at the 99% chance, and so what that means is that when you're looking at the 99% chance of safety, or the point 0.0001% chance of something bad happening, you have to include all of the things happening. And I think that's why it's common to think about all the bad negative things that can happen and say, I'm not okay with that risk, because you're including all of those in your calculations, which, you know, you do include all those things in your calculations. That's what we see here. Um, but the truth of the matter is that, um, again, are you looking at a lifetime of data? Are you looking at 1 year of data? Are you looking at the last 3 years of data, right? That matters too, because as you can see here, over the lifetime, we can expect 10% every month versus a 5% the last year and 7% the last 3 years. So it makes a difference. It makes a difference. And so the other thing I thought was really interesting, and why I kept this here, is that at the 70%, and this is mathematically 70%, okay, not the empirical data, rule of thumb type thing. This is just the actual numbers. All right, based on last year's data, right? The worst case scenario for this portfolio is actually a gain every month, and that's what this number means here, right? 0.16 is a positive. These other numbers here for the lifetime is negative 0.58, which is a loss, and these other ones for the last 3 years is negative 0.14. But for the last year of data, right, the worst case scenario is that there will be a gain every single. And so, again, I like to think conservatively, right? I like to think more worst case scenario situation, and so I don't use that 70%. I do use the empirical data that I will say is 70%, but mathematically it's really 84%. Okay. Anyway, I thought that was interesting. Again, I'm happy with the performance of the portfolio thus far. Looking at these numbers is really cool. 200 a month. Last year, 400 a month. Last 3 years, 300 a month. It's not bad money. And so anyway, look forward to continuing following these numbers and looking at the data, and just seeing kind of what's happening, and